Definition of a function. A relation R from A to B is said to be function if for every element in set A there exists unique element in set B. If the relation R satisfies this condition, then we say R is a function. If you observe this condition, every element in set A, there exists unique element in set B. Unique element. Unique element means only one element. Now I'll try to explain the definition of function with the following examples. Now I'll consider a relation R from A to B. If you observe this relation R from A to B, 1 is related to 4, 2 is related to 5, 3 is related to 4. If you observe for the element 1, how many elements there exist? Only one element, that is 4. For the element 2, there exists only one element, that is 5. For the element 3, there exists only one element, that is 4. For every element in set A, there exists only one element in set B. Don't confuse with the elements 1 and 3 are having same element. Same element is different, unique element is different. So it satisfies the condition that for every element in set A, there exists only one element in set B. Therefore, R from A to B is a function. In other words, we can observe like this also. For every element in set A is used and it is used only once. In this way also you can observe. Observe this example. Every element in set A is used and it is used only once. Because of that reason also we can say that R is a function from A to B. Now we'll try to understand with one more example. Consider a relation R from A to B. You observe this relation. For every element in set A, there exists unique element in set B or not. Observe that 1 is related to 5, 2 is related to 4, 3 is related to 6. You observe that for every element in set A is used, it is used only once. With this reason we can say that R is a function from A to B. Or you can observe this. For every element in set A, there exists only one element in set B. For 2, only one element. For 3, only one element. For every element in set A, there exists only one element in set B. So R is a function from A to B. Now we will try to understand the definition of function with one more example. Now I'll consider a relation R from A to B. You observe this relation. For every element in set A, there exists unique element in set B or not. 1 is related to 5. 1 is related to 4. 2 is related to 6. 3 is related to 6. You observe that for the element 1, there exists two elements 4, 5 in set B. For the element 2, there exists only one element. For the element 3, there exists only one element 6. It can be observed easily that we can observe that for the element 1 in set A, there exists two elements 4, 5 in set B. So uniqueness fails. Therefore, R from A to B is not a function. Now I'll try to explain the definition of function with one more example so that you will get more clarity about this definition. R is a relation from A to B, and this relation is as follows. One is related to 4. 2 is related to 5. You observe here in this example, for the element 3, there is no element in set B. That means every element in set A is not used. Because of this reason, we can say that R is not a function from A to B. I hope you understand definition of a function. Thanks for watching. Domain, codomain, image, pre-image and range of a function. Consider a relation f from A to B. The set A contains elements A, B, C, D. The set B contains elements 4, 5, 6, 7. And the relation is like this. B is related to 4, C is related to 7, D is related to 6, A is related to 6. You observe set A. Every element in set A is used. It is used only once. It means for every element in set A, there exists only one element in set B. Therefore, f from A to B is a function. About function we already learned in last class. If f is a function from A to B, then set A is called domain and set B is called codomain. You observe set A, this is domain. Observe this set B, this is codomain. Image of an element A is 6. Observe here, A is related to 6. That's why we say image of A is 6. Similarly, observe the diagram. Image of an element B is what? 4. Image of an element C is 7. Image of an element D is what? Yes, 6. Very good. Pre-image of 6 is A. Pre-image of 4 is B. Observe here, B is related to 4. So, pre-image of 4 is B and image of B is 4. Range. The set of all images of set A is called range of the function f. All images of set A, observe the diagram, all images of set A are in B. What are those? 4, 6, 7. Now we will see domain of the function. What is domain of the function? Set A, B, C, D. Now we will see codomain of the function. What is codomain of the function? Set B, 4, 5, 6, 7. Range. Range of the function is what? Set of all images 4, 6, 7. In this we don't get the element 5. 4, 6, 7 are the set of all images of set A. We often write like this, f of A equals to 6. It means that image of A with respect to f is 6 and pre-image of 6 is A. F of A equals to 6. It means that image of A with respect to f is 6. Now you see this f of x equals to y. It means that image of x with respect to f is y and pre-image of y is x. The definition of constant function and example to understand the definition of constant function, what is domain, codomain and range of a constant function, and we will learn how to draw the graph of constant function. First we will see the definition of constant function. A function f from R to R. You observe here a function f from R to R defined by f of x equal to c for any x belongs to R. The symbol is for any x belongs to R. is called a constant function. Which function is constant function? Function from R to R defined by f of x equal to c for any x belongs to R is called a constant function, where c is a constant. What is constant means? Constant means it's a fixed number. For example, you see here, I'll fix c equal to 1. I'll take this c value as 1. Then f of x value is 1 for any x belongs to R. It tells that f of 1 is 1. F of 2 is also 1. F of 1.3, that is also 1. F of 5 is 1. F of 10 is 1. F of 30 is 1. F of 1 lakh, that is also equal to 1. What I am trying to say, the function is defined as f of x equal to some fixed number. What is x? X is any real number. You can understand this more clearly with this example. You observe this example. You can see here every element of set A is used. It is used only once. So this is a function. First of all, it is a function. Now you can see f of 1 is b. What is f of 1 as per this diagram? F of 1 is b. What is f of 2? F of 2 is b. What is f of 3? F of 3 is b. Image of 4? Image of 4 is also b. Image of 5? Image of 5 is also b. What you can understand here from the diagram, we can understand that f of x equal to c for any x belongs to set A. For any x belongs to set A. This is a function. Moreover, this function is known as constant function. Not only this, if all the elements of set A are matched to only A, that means image of 1 is A, image of 2 is A, image of 3 is A, image of 4 is A, image of 5 also A, then that function is also known as constant function. I hope you are understanding what is constant function. Now we will see what is its domain, codomain, range of a constant function. We know that f is a function from A to B. Then this set A is called domain. That we learn in the definition of domain of a function. Here it is a function from set of all real numbers to real numbers. So what is domain of this function? Domain of this function is all real numbers. Okay. And what about codomain of a function? In the definition of codomain of a function, we know that if f from A to B is a function, then set B is called codomain, right? So here f is function from set of all real numbers to real numbers. So what is codomain of this function? See here, what is codomain of this function? Codomain of this function is all real numbers. So for this, codomain is set of all real numbers. What is range of constant function? What is the definition of range? Set of all images of domain set is called range. Set of all images of domain set. See, you take any real x. F of x is c. That means image of x is c. F of 1 is c. F of 2 is c. F of 5 is c. You take any real value, its image is c. That means all images of domain set is c only. So what is the range? Range is a singleton set. It contains only one element, that is c. What is c? It's a constant fixed number. So we learn domain, codomain, range of a constant function. Now we will learn how to draw the graph of constant function. Okay, you observe here, I just consider coordinate axis, x-axis, y-axis. Now I need to draw the graph of constant function. You see here, we know that f of 0 is what as per the definition? F of 0 is a fixed number c. F of 0 is c. Here c is some fixed number. So I am taking here, this is the c value. Just for example, I taken it. You can take c value here also. Anywhere you can take on y-axis c value. C is a fixed number. I consider c like this. Now, what is the point? This point is 0, c. See, look here, the point 0, c lies here. This is the point 0, c. F of 1 is what? F of 1 is c. As per the definition, f of 1 is c. So, 1, c, where the point 1, c lies? This is the point 1, c. Now, f of 2 is what? F of 2 is also c. So, where the point 2, c lies? This is the point 2, c. You know how to plot the point on the graph. This length is 2 units, this length is c units, right? Next, f of 3. F of 3 is also c. Where is the point 3, c? This is the point 3, c. Similarly, f of minus 1 is c. F of minus 2 is c. F of minus 3 is c as per the definition. So, this is the point minus 1, c. This is the point minus 2, c. This is the point minus 3, c. You join all these points, what you will get? You observe, I am joining all these points. If I join all these points, what happening? What happening? I am getting a straight line which is parallel to x-axis. Yes. Therefore, the graph of constant function is a straight line which is parallel to x-axis. So, this is the graph of constant function. I'll give a note here. What you observe in this graph? Therefore, graph of a constant function is a straight line which is parallel to x-axis. I quickly recall what we learned in this class. We learned the definition of constant function. A function f from set of all real numbers to real numbers defined by f of x equal to c for any x belongs to R is called constant function. And domain of constant function is set of all real numbers. Codomain of constant function is set of all real numbers. Range of constant function is a singleton set which contains a constant c. And while drawing the graph of constant function, we understood that constant function graph is a straight line which is parallel to x-axis. The definition of identity function. Example to understand identity function, and we will learn how to draw the graph of identity function. First, we will learn the definition of identity function. A function f from set of all real numbers to real numbers defined by f of x equal to x for any x belongs to R is called identity function. In this definition, what you need to understand? First thing, this function is from where to where? This function is from set of all real numbers to real numbers. And how the function is defined? The function is defined as f of x equal to x for any real x. You can take x as any real number. For example, f of x is defined as x na? You see here, f of 1 is what? F of 1 is 1. F of 2 is what? F of 2 is 2. You take x as any real number, the function is defined as f of x is x. For example, f of minus 1 is what? F of minus 1 is minus 1. F of 100 is what? F of 100 is 100. F of 2.5 is what? F of 2.5 is 2.5. F of 3 by 2 is what? F of 3 by 2 is 3 by 2. You take any real x. For any x belongs to R, f of x is defined as x. We'll try to understand this identity function with an example. You observe this example. Is it a function or not? Every element of first set is used. It is used only once. So, it is a function. Now, we need to check this function is identity function or not. When we say this function is identity function, you see here, f of 1 is what from the diagram? You observe the diagram, f of 1 is what? 1. You see, f of x equal to x form. What is f of 2 from the diagram? F of 2, image of 2 is 2. What is f of 3? Image of 3 is 3. F of minus 3 is minus 3. What happened here? Here, this function satisfies this condition, f of x equal to x. Can we say this function as identity function? Yes, f from a to b is a identity function. Now, we will learn what is domain, codomain, range of a identity function. What is domain of identity function? We know that f is a function from set A to set B. Then, what is the set A? Set A is called domain. This is the definition of domain. What about set B? Set B is called codomain. These are the things we learn in the definition of domain and codomain of a function. Here, this function is from where to where? Set of all real numbers to real numbers. So what is the domain of this function? You please observe here. What is the domain of this function? Domain is a set of all real numbers. For identity function, domain is set of all real numbers. What about codomain? What is codomain? You observe here, f is a function from a to b. Set b is called codomain. So this is a function from R to R. What is codomain of identity function? Codomain of identity function is all real numbers. What is range? What do you know about definition of range? We know that range is set of all images of domain set. Set of all images of domain set. What is domain here? Domain is all real numbers. As per the definition, f of x is x. When x is a real number, its answer is also real number. Try to understand. So here, what is the range of the function? Range of the function is set of all real numbers. So it is very easy to remember domain, codomain, range of identity function. Domain is set of all real numbers. Codomain is set of all real numbers. Range is also set of all real numbers. Now we will learn how to draw the graph of identity function. You observe here, I consider a coordinate axis and I consider some x values. For respective functional values, we will see. When x is 0, what is f of 0? As per the definition, f of 0 is 0. What is f of 1? As f of x is x, f of 1 is 1. Okay? F of 2 is 2. F of 3 is 3. F of minus 1 is minus 1. F of minus 2 is minus 2. F of minus 3 is minus 3. Why? Because f of x equal to x. If I want to draw the graph, I need to plot these points. You see here 0, 0. Where is the point 0, 0? You can observe here. This is the point 0, 0. Point 1, 1. Where will be the point 1, 1? Here, this is the point 1, 1. 2, 2. 2, 2. See, you know how to plot the points on the graph. This is the point 2, 2. This length is 2 units. This length is 2 units. Next point is 3, 3. 3, 3. This is the point 3, 3. This length is 3 units. This length is also 3 units. Minus 1, minus 1. We know that it lies in third quadrant. Minus 1, minus 1. Okay. Minus 2, minus 2. It will be here. Minus 2, minus 2. Next, minus 3, minus 3. You will get this point here. Minus 3, minus 3. Now, you join all these points. We will see what happens. You just observe. I am joining all these points. What happens? If I join all these points, what happening? I am getting a straight line which is passing through origin. So this is the graph of identity function. What you observe in this graph? The graph of identity function is a straight line which is passing through origin. I'll give it as a note point. Graph of identity function is a straight line passing through origin and lies in first and third quadrant. You can observe this is the graph of identity function. It is a straight line passing through origin and it lies in first quadrant and third quadrant. In this class, we learn the definition of identity function and we learn what is domain, codomain, range of identity function, and we learn how to draw the graph of identity function, the definition of modulus function, and examples to understand the definition of modulus function. And we will learn domain, codomain, range of a modulus function. And we will learn how to draw the graph of modulus function. First, we will learn the definition of modulus function. A function f from set of all real numbers to real numbers is defined by. The function is from where to where? Set of all real numbers to real numbers. And it is defined like this. You observe here, the function is defined like this. F of x is modulus of x. We read it as modulus of x. Modulus of x will be x whenever x greater than or equal to 0. Modulus of x is minus x when x is less than 0. We'll understand this more clearly when we do examples. Okay, so first I am writing the definition. What is the definition of modulus function? The function is defined like this, is called modulus function. We'll try to understand how the function is defined with examples. See here what they given. Modulus of x value is x when whenever this x is greater than or equal to 0. Modulus of x value is minus x when x value is less than 0. Okay, here I'll take modulus of 3. You observe here whatever the expression is there here, this expression 3 is greater than 0 or less than 0. 3 is greater than 0. So it comes to the first case. So modulus of x will become what? Modulus of x will become x. So as 3 is a positive number, modulus of 3 is 3 only. For example, if I take modulus of 5 divided by 4. Here you observe that whatever the expression 5 by 4 is there, this 5 by 4 is greater than 0 or less than 0. 5 is positive, 4 is positive, 5 by 4 clearly positive. Positive number means it is greater than 0. So 5 by 4 is greater than 0. It comes to which case? It comes to the first case. Then modulus of x is what? Modulus of x can be written as x. So what is modulus of 5 by 4? Modulus of 5 by 4 is 5 by 4. Modulus of 1 lakh. You observe this 1 lakh is positive or negative? 1 lakh is positive. That means it comes under first case or second case? It comes under first case. So modulus of 1 lakh is what? Modulus of 1 lakh is 1 lakh only. Now modulus of 0. Modulus of 0. You observe this expression 0. Here in place of x, 0 is there. X equal to 0. You observe this first case when x is greater than or equal to 0. When x equal to 0, which function to choose? First function or second function? This first function. Modulus of x is x. So modulus of 0 is what? Modulus of 0 is 0 only. Till here no confusion. Now you see here this second one. It is important. Modulus of minus 3. You please try to understand. This minus 3 is less than 0 or greater than 0. Minus 3 is less than 0. It is under second case. That means x is less than 0. When x is less than 0, what is modulus of x? Modulus of x is minus x. Minus x. Here modulus of minus 3 is minus x. That means what is there here? Same image you need to write. Here in place of x what is there? Minus 3 is there. That means you need to write minus 3. Please try to understand. It is tricky one but very easy. Minus of minus is plus. So this is 3. So what is modulus of minus 3? Modulus of minus 3 is 3. So here modulus of minus 9 is there. What is modulus of minus 9? You observe about this minus 9. Minus 9 is negative, correct? Yes, minus 9 is less than 0. When x is less than 0, modulus of x is minus x. Minus x. Modulus of minus is what? Minus. What is x? In place of x here minus 9 is there. Minus of minus 9 is what? Plus 9. So what is modulus of minus 9? Modulus of minus 9 is plus 9. Consider that modulus function is a positive mission. If you give positive number to modulus function, it gives positive number only. Look here. If you give negative number to the modulus function, it makes it positive. What is modulus of minus 100? What is modulus of minus 100? It is plus 100. Why? Because as per the definition, when x is negative, modulus of x is minus x. So minus of minus 100 is 100. I hope you are understanding. So these are the examples to understand modulus function. Now we will write what is domain, codomain, range of a modulus function. Domain. What is domain of a modulus function? We learn from the definition, if f from a to b is a function, then set A is called domain, correct? Set A is called domain. Here this is a function from where to where? Set of all real numbers to real number. So here you observe this one. This is domain of modulus function. So what is domain of modulus function? Domain of modulus function is all real numbers. And what about codomain of modulus function? Codomain. If f from a to b is a function, then what is set b? Set b is called codomain. Set b is called codomain. Here you see this function is from where to where? Set of all real numbers to real numbers. Now what is codomain of this function? Codomain of this function is set of all real numbers. Now we will try to understand range of modulus function. This is important. Range of modulus function. What is range definition? Set of all images of domain set. Set of all images of domain set is called range of the function. You see here modulus of 3 is what? 3. That means image of 3 is 3. What is image of 5 by 4? Image of 5 by 4 is 5 by 4. Image of 1 lakh is 1 lakh. Image of 0 is 0. Image of minus 3 is what? Image of minus 3 is plus 3. Image of minus 9 is what? Image of minus 9 is plus 9. Image of minus 100 is plus 100. Image of minus 1 by 2 is what? Image of minus 1 by 2 is plus 1 by 2. What you understand here, all images you observe, all images are positive real numbers. So 0 is possible or not? You observe this. Modulus of 0 is what? Modulus of 0 is 0. So what is the range of this function? Range of this function is closed interval 0 to open interval infinity. That means all positive real numbers including 0. Okay, so the range of modulus function is all positive real numbers including 0. Now we will learn how to draw the graph of modulus function. You observe here, I considered a coordinate axis. Here I considered some x values. When x is 0, that means modulus of 0 is what? Modulus of 0 is 0. Modulus of 1 is 1. Modulus of 2, modulus of 2 is 2. Modulus of 3, modulus of 3 is 3. What is modulus of minus 1? We know that modulus is a positive mission. If we give negative number to it, it makes it positive. Modulus of minus 1 is plus 1. Modulus of minus 2 is plus 2. Modulus of minus 3 is plus 3. Now, I'll plot all these points in this. You see, first point is 0, 0. Where is the point 0, 0? You can observe this is the point 0, 0. Now, the point 1, 1. Here is the point 1, 1. This is the point 1, 1. Next point 2, 2. Where is the point 2, 2? Here. You know how to plot the points on the graph paper. Okay. Now, the point 3, 3. Here. This is the point 3, 3. Okay. Now, next point is minus 1, 1. X is negative, Y is positive. It lies in which quadrant? It lies in second quadrant. So this is the point minus 1, 1. Okay, this is point minus 1, 1. Minus 2, 2. See, you observe here, this is the point minus 2, 2. Okay, next minus 3, 3. Where is the point minus 3, 3? You look here. This is the point minus 3, 3. Now you observe, I'll join these dots. We'll see what happens. Here you observe this. It is like a straight line. We got this like a straight line. And you join this side also. We'll see what you will get. You observe here, we got a V symbol. Modulus function is V symbol. Which graph it is? This is the graph of modulus function. So what we learn in this class, we learn the definition of modulus function. And we learn what is its domain, codomain, range of a function. And we learn about how to draw the graph of a modulus function and how the graph of modulus function looks. It is very easy to remember the graph of modulus function. Graph of modulus function looks like a vector symbol, V symbol, right? In this class, we will learn the definition of Signum function. And we will learn domain, codomain, and range of a Signum function. And we will learn how to draw the graph of Signum function. First, we will learn the definition of Signum function. A function f from R to R. It is a function from set of all real numbers to real numbers. You observe here, the function is defined like this. F of x is 1 when x is greater than 0. F of x is minus 1 when x is less than 0. F of x is 0 when x equal to 0. I'll try to explain this more clearly with an example. First, let me finish the definition. A function f from R to R defined like this is called Signum function. Now, I'll try to explain this with few examples. F of 2. What is f of 2 value? As 2 is greater than 0, we need to choose this function. Which function? F of x is 1. So what is f of 2? F of 2 value is 1 because this 2 is greater than 0. What is f of 100? We know that 100 is greater than 0. When x is positive, f of x is 1. So f of 100 is 1. Okay. F of 1.5. 1.5 is greater than 0 now. So which function to choose? First function. So f of 1.5 is 1. I hope you are understanding. Similarly, f of minus 2. You observe this minus 2 is less than 0. So in these three functions, which function to choose? When this x value is less than 0, we need to choose this middle function. What is middle function? Minus 1. So f of minus 2 is what? F of minus 2 is minus 1. When x is negative, we need to choose f of x as -1. So f of -100. What is f of -100? As -100 is less than 0, f of -100 is -1. What is f of -1/2? What is f of -1/2 is less than 0 now. So we will take -1. What is f of 0? Here you observe, in place of x, 0 is there. F of 0. If x is 0, which function to choose? Third function, that is 0. F of 0 is what? 0. I hope you are understanding. Now, from this, I'll write domain, codomain, and range of Signum function. Domain of the Signum function. We know that f is a function from a to b. Then set A is called domain. Okay, this A is called domain. This function is from all real numbers to real numbers. So this R is called domain of the function. Domain of this function is set of all real numbers. Okay, domain is over. Now codomain. What is codomain? If f from A to B is a function, then set B. What is this set B? Set B is called codomain, right? Here, what is codomain? This function is from R to R. So what is this R? This R is codomain. Codomain is what? Codomain is set of all real numbers. Domain is all real numbers. Codomain is also all real numbers. Now I'll write range of Signum function. What is range definition? Set of all images of domain set. Set of all images of domain set. You observe here, f of 2 is 1. What is image of 2? What is image of 2? Image of 2 is 1. Image of 100? Image of 100 is 1. Image of 1.5, 1. Whenever x is positive, its image is 1. You see here, f of -2 is what? F of -2 is -1. That means image of -2 is -1. Image of -100, -1. Image of -1/2, -1. What you observe? When x is negative, for all negative numbers, its image is -1. When x is 0, what is image of 0 here? Image of 0 is 0. What I am trying to say, what is the definition of range? Set of all images. If you observe the images here, the images will be either 1 or -1 or 0. So, what is the range of the Signum function? 1, -1, 0. Now, we will learn how to draw the graph of Signum function. To draw the graph, I consider a coordinate axis, x-axis, y-axis, and you observe here, I consider some x values. I cannot take all real numbers, so I consider some x values here. When x is 0, what is f of x? What is f of 0? F of 0 is 0. When x is 1, what is f of 1? As 1 is greater than 0, f of 1 is 1. What is f of 2.5? 2.5 is greater than 0. So f of 2.5 is 1. We need to choose the first function. F of 3. As 3 is greater than 0, f of 3 is 1. F of -1. As -1 is less than 0, f of -1 is -1. F of -1.5. As -1.5 is less than 0, f of -1.5 is -1. F of -2. As -2 is less than 0, f of -2 is -1. Okay. Now, you plot these points on the graph. Where is the point 0, 0? This is the point 0, 0. Where is the point 1, 1? See here, this is the point 1, 1. Where is the point 2.5, 1? Look here, 2.5, 1. You will get here 2.5, 1. Where is the point 3, 1? You will get 3, 1 here. Next, -1.5, 1. This is the point -1.5. Here -1.5, -1. Okay. Next, -2, -1. Okay. Similarly, if I write -3 here, f of -3 is -1. Okay. Now, you join all these points. You observe here what you are getting. I am joining all these points. The graph is continuing like this, right? So here, you need to observe it's an open circle. Now, you observe here, if I join here all these points, then you will get like this. So, what is this? This is the graph of Signum function. The Signum function graph looks like this. I hope you understand this class. In this class, what we learn? We learn the definition of Signum function. We learn what is its domain, codomain, and range. and we learn how to draw the graph of Signum function, the definition of greatest integer function, domain, range of a greatest integer function, and we will learn how to draw the graph of greatest integer function. Greatest integer function is also known as floor function. Greatest integer function is also known as step function. I'll tell you why they named it as floor function, step function after completion of the graph. First, we will learn the definition of greatest integer function. A function f from real numbers to real number. This is a function from where to where? Real numbers to real numbers. And how the function is defined? The function is defined like this. It is defined as f of x equal to, look here, we read it as greatest integer value of x, or simply we read it as step x. Here, from now onwards, I'll read this as step x. The function is defined as f of x equal to step x. And what is step x? It is greatest integer less than or equal to x. I'll explain this with examples. First, let me complete the definition. Greatest integer less than or equal to x is called greatest integer function. What is greatest integer function? A function f from real numbers to real numbers is defined as, how it is defined by? F of x equal to step x. What is step x? Step x is greatest integer less than or equal to x is called greatest integer function. Now, I'll explain this with examples. Okay. In this definition, this is the important thing. F of x equal to step x. Step x is greatest integer less than or equal to x. For example, if you want to find step 1.5, what is the value of step 1.5? See here, greatest integer less than or equal to. This equal to we use only when this x is an integer. So for time being, you just forget about this equal to. Step 1.5 is what? Step 1.5 is greatest integer less than x. X is what here? X is 1.5. Step 1.5 means greatest integer less than 1.5. You observe here, I just considered a number line. You identify where is 1.5 in this number line. You can see this is 1.5, correct? You observe the integer less than 1.5. Look this part only. Integer less than 1.5. You see, this is integer less than 1.5. This is integer less than 1.5. This is integer less than 1.5. All these are integers. All these are what? All these are integers which are less than 1.5. What they are asking? In these integers, greatest integer. In all these integers, which one is greatest? Look here, which one is greatest? One is the greatest integer which is less than 1.5. Please try to understand. So what is step 1.5? Step 1.5 is 1. What is step 2.34? What is step 2.34? What it means? It means that greatest integer less than 2.34. You identify where is 2.34 on the number line. See, this is 2.34. Okay. Now you mark all integers which are less than 2.34. This is integer less than 2.34. This is integer less than 2.34. All these are what? All these are integers which are less than 2.34. In these integers, which one is greatest? You see here. This is greatest. So what is step 2.34? Step 2.34 is 2. I hope you are understanding. Now you see step minus 1.5. Many students will confuse at this point. What is step minus 1.5? It means that greatest integer less than minus 1 point. First point, you observe where is minus 1.5 on the number line. You can see this is minus 1.5, correct? Now you mark all integers which are less than minus 1.5. Integers less than minus 1.5. See, this is integer which is less than minus 1.5. This is integer which is less than minus 1.5. This is integer. Like that, all these numbers, left side numbers, are integers less than minus 1.5. You can see in these integers, which one is greatest? Which one is greatest? Minus 2 is greatest. Minus 2 is the greatest integer less than minus 1.5. So what is the answer here? Answer is minus 2. See, instead of checking like this every time, we have a trick to tell its values immediately. Suppose if you want to tell step 1.5 value, what you'll do, you identify this 1.5 is in between what integers? You see 1.5 is here in between 1 and 2. So left side what number is there? That is the answer. Step 1.5 is 1. Okay. Similarly, you see step 2.34. Where is 2.34 on the number line? You see this is 2.34 on the number line. You observe that this is in between what integers? This is in between the integers 2 and 3. In left side what number is there? That is the answer. So step 2.34 is 2. Similarly, you observe here step minus 1.5. You mark minus 1.5 on the number line. You identify it is in between what integers? It is in between minus 2 and minus 1. Left side what number is there? That is the answer. Left side what number is there? Minus 2 is there. So that is the answer. Okay. Now you observe, I'll write a few values very quickly. Step 3.41. You observe that 3.41 is in between integers 3 and 4. Left hand side what number is there? That is the answer. Step 3.41 is 3. Now I'll calculate one more. Step minus 2.91. You observe minus 2.91 is in between what integers? You can see this is, it is in between the integers minus 3, minus 2. Left hand side what number is there? What integer is there? That is the answer. Step minus 2.91 is minus 3. Minus 0.5. How to find its value? You identify where is minus 0.5 on the number line. You see here this is minus 0.5. This is in between what integers? This is in between minus 1 and minus 0. Left side what number is there? Left side minus 1 is there. So step minus 0.5 is minus 1. So I hope you understand step x is greatest integer less than x. Now we'll discuss about greatest integer less than or equal to x. For example, you see here, now I want to find step 2 value. Step 2 value. What is step 2? Greatest integer less than or equal to 2. Here you mark 2 on the number line. See, this is 2 on the number line. Greatest integer less than 2 means all these things will come. All these are greatest integers. All these are integers less than 2. Here equal to 2 also coming. Try to understand. Step 2 means greatest integer less than or equal to 2. Here equal to 2 also coming. 2 is an integer. This is an integer. Try to understand. So this also we will consider. These are all the integers which are less than or equal to 2. In all these integers, which one is greatest? Which one is greatest means 2 is the greatest. Why all this confusion? Very simple. Whenever integer is there, its answer is integer only. Step 4 is 4. Step 5 is 5. Step 0. Step 0 is what? Step 0 is 0. Step minus 1. Step minus 1 is what? Step minus 1 is minus 1. Step minus 2. Step minus 2 is what? Minus 2. Okay. So last two examples. Step 1.98. Yes, what it is? It is in between integers 1 and 2. Left hand side 1 is there. So answer is 1. Step minus 3.98. It is in between minus 4 and minus 3. So left hand side what number is there? Minus 4 is there. I hope you understand how to calculate greatest integer values. Now I'll write its domain, codomain, range. Domain. From the definition of a function, we know that f from a to b is a function. Listen, if f from a to b is a function, then this set A is called domain. So here this is the function from real numbers to real numbers. So what is the domain of this function? Domain of this function is this set. What is this set? This set is R. So domain of greatest integer function is set of all real numbers. F is a function from A to B. Then what is set B? Set B is codomain. Set B is called codomain. Here this is a function from real numbers to real numbers. So what is codomain? Codomain is set of all real numbers. Now important one. what is range of greatest integer function? Range. What is the definition of range? Set of all images is called range. You observe here, what is image of 1.5? Image of 1.5 is 1. What is image of 2.34? Image of 2.34 is 2 with respect to step function. Step minus 1.5 is minus 2. That means image of minus 1.5 is minus 2. Image of 3.41 is 3. You observe all these answers. You observe all these answers, please. You observe all the answers. Is there anywhere fraction is there? No. What all these answers are? All these answers are integers. You can observe that all these answers are integers. Whatever real number you take in domain set, its answer is an integer. So all images are integers here. So what is the range of a function? Range of the function is set of all integers. Okay. Now we will learn how to draw the graph of greatest integer function. You observe here, I considered coordinate axis to draw the graph. And you look here, I consider some x values and I'll write corresponding step x values. When x is 0, what is step 0? Step 0 is 0. Step 0.3. Step 0.3 is what? 0. Step 0.6, 0. Step 0.9, 0. Step 1, when it is an integer, answer is integer only. Step 1 is 1. What I'll do, I'll mark these points on the graph. Mark these points. First point is what? 0, 0. So the 0, 0 is a part of the graph. This is included. 0.3, 0. Where is that 0.3, 0? It is on x-axis. 0.3, 0. 0.6, 0. Where is that 0.6, 0? Here that is 0.6, 0. 0.9, 0. This point 0.9, 0. When x is 1, f of x value is 1. Where is the point 1, 1? Here is the point 1, 1. Please try to understand this carefully. So what happens? If we join all these points, you will get a graph like this. Here the important point is this 1 is not included. It's an open circle. You need to observe this carefully. Okay. So I'll take a few more x values here. We will see what happens. Now you observe here, when x is 1, step 1 is 1. Step 1.3, step 1.3 is 1, step 1.6 is 1, step 1.9 is 1, step 2 is what? Step 2 is 2. So here I'll mark all these points. We already marked the point 1, 1. This is 1.3, 1. 1.6, 1. It will be here 1.6, 1. 1.9, 1. That will be here. When x is 2, step 2 is 2. When x is 2, step 2 is 2. That means the point 2, 2 will be here. So if we join all these things, what happens? Now you observe here, this point is not included. What point this is actually? 2, 1 is not included. So the graph will come like this. I hope you are understanding. You can see this side closed circle is there, this side open circle is there. Similarly, if you continue the graph will come like this. You please check for all other values. The graph will come like this. And I said I'll tell you why they named it as a step function. You can observe this graph. It looks like steps. It looks like floor steps. That's why it is known as floor function also. If I further continue this graph, you will get graph like this. You see? And left side is closed circle and this right side you need to draw open circle. That means this point is not included. Further, if we continue this, the graph will be like this. Okay. It is important to remember how the graph of greatest integer function is. It is not compulsory to write these values and to draw the graph. Just to explain how this graph we will get, I taken some of the x values. How the greatest integer function looks? It looks like a floor steps. And this left side part is closed circle, right side part is open circle. I hope you understand this class. In this class, what we learn? We learn the definition of greatest integer function and examples to understand greatest integer function. We learn domain, codomain, range of greatest integer function, and we learn about graph of greatest integer function. The definition of polynomial function, types of polynomial functions, domain, codomain, and range of a polynomial function. First we will learn the definition of polynomial function. You see here polynomial. What is meant by this word polynomial? Poly means many, nominal means terms. Polynomial means many terms. So this is the meaning of polynomial. Polynomial means many terms. Polynomial function. What is polynomial function? It is a function from real numbers to real numbers. It is defined as f of x equal to a0 plus a1x plus a2x square plus and so on plus an x power n. Here if an is not equal to 0, then it is called a polynomial function of degree n. You can observe here polynomial means many terms. You see here many terms are there. Here what about a0, a1, a2 and so on an, where a0, a1, a2 and so on an are real numbers. And what about this n? N is non-negative integer. What is n? Non-negative integer. What is this? This is the definition of polynomial function. In examination, if they ask define polynomial function, you should write like this. Now I'll try to explain what is this polynomial function with examples. You observe here, it is a polynomial function. You see it is of this form, a0 plus a1x. Here x power 1 is there. Okay, so this function is of this form only. Is it a polynomial function? Yes, it is a polynomial function of degree 1. This is a polynomial function of degree 1. Moreover, this is also known as linear function. This is the polynomial of degree 1. This polynomial is known as linear function. Okay, you observe this example, a0 plus a1x plus a2x square. Is this function is of this form? Yes, this function is of this form. So what we say this function? It is a polynomial function of degree 2. Moreover, this function is also known as quadratic function. You observe this function. What is the highest power in this? Highest power is 3. You can observe this function is of this form. And here its degree is 3. So is it a polynomial function? Yes, it is a polynomial function of degree 3. Moreover, it is known as cubic function. So here I given 3 examples. All these 3 are polynomial functions. This is a polynomial function of degree 1. This is a polynomial function of degree 2. This is a polynomial function of degree 3. Moreover, these functions are named like this. Now we will see examples which are not polynomial function. You observe this function. This function is x power 2 by 3 plus 2x. Is it a polynomial function? You observe here in this definition, what is n? N is non-negative integer. N must be integer. Moreover, it is not a negative integer. Here you see this 2 by 3. This 2 by 3 is an integer? No, it is not an integer. So it is not a polynomial function. Therefore, this function is not a polynomial function. Now it comes to domain, codomain, range of polynomial function. What is domain of this function? We know that if f is a function from a to b, then set A is called domain and set B is called codomain. Okay, so for this function, what is domain? Domain is set of all real numbers. What about codomain? You see here, if f from a to b is a function, b is called codomain. So here, what is codomain? Codomain is set of all real numbers. Codomain is set of all real numbers. And what about range of polynomial function? For different real x values, f of x will gives you different real numbers. So the range of polynomial function is all real numbers. How to draw the graph of f of x equal to x cube? You observe what they given in the question. Draw the graph of the function f from real numbers to real numbers. It is defined by f of x equal to x cube for any x belongs to R. We need to draw the graph of x cube. This graph is important. We use very frequently while solving JEE problems. It is important to remember how the graph of x cube looks. However, here I'll take some x values, functional values to draw the graph of x cube. First, I written given information. What they given? F is from real numbers to real numbers. It tells that this function domain is all real numbers. Codomain is all real numbers. And f of x is defined as x cube. To draw the graph of f of x equal to x cube, I'll take x values, functional values like this. You observe here, when I take x is 0, f of 0 is 0 cube. 0 cube value is 0. F of 1 is 1 cube. 1 cube is 1. F of 2. 2 cube is 8. F of 3. F of 3 is 3 cube. 3 cube is 27. F of minus 1. Minus 1 whole cube is minus 1. F of minus 2. Minus 2 whole cube is minus 8. F of minus 3. Minus 3 whole cube is minus 27. However, I cannot take all real x values. So that's why I taken sum of x values here. Now, I'll plot all these points on the graph. Okay, you observe here, I consider a coordinate axis, x-axis, y-axis, and we need to plot these points on this graph paper. First one is 0, 0. We know that the point 0, 0 will be here. Okay. Next point 1, 1. The point 1, 1 will be here. This is the point 1, 1. Next point is 2, 8. Here x value 2, here 8 is there. This is 2, 8. Similarly, if I take x is 3, you will get 27 somewhere around here. So this is a 3, 27. Okay. Now we need to plot the point minus 1, minus 1. X is negative, y is negative in third quadrant. You see, this is the point minus 1, minus 1. Next, minus 2, minus 8. X is negative, y is also negative, it lies in third quadrant. Minus 2, minus 8, the point lies here. This is the point minus 2, minus 8. Minus 3, 27, somewhere around here you will get. This is minus 3, 27. You just join these points and you see how the graph looks. You observe here, I joined the points and I got like this. What is this? This is the graph of the function f of x equal to x cube. We use this graph very frequently while solving JEE problems. Instead of marking the points on the graph and drawing like this, you just remember how the graph of f of x equal to x cube looks. Definition of fractional part of function. We will learn domain, codomain and range of fractional part of function and examples to understand the definition of fractional part of function, and we will learn how to draw the graph of fractional part of function. First, we will learn the definition of fractional part of function. A function f from real numbers to real number. A function which is from real numbers to real numbers. Defined by f of x equal to x minus step x. Look here, in previous classes we learned what is step function. Here f of x is x minus step x is called fractional part function. Now first I'll explain what is this function f of x equal to x minus step x with examples. Afterwards I'll give the notation of fractional part of function. Here this is the function given f of x as x minus step x. This is fractional part of function. Here I'll calculate f of 1.5. What is f of 1.5? As per the definition, f of 1.5 is 1.5 minus step 1.5. Okay, if we simplify this further, what you will get? 1.5 minus step 1.5. In previous classes, we learned the value of step 1.5. Step 1.5 value is 1. So, what you will get? You will get 0.5. F of 1.5 is 0.5. You have to observe one thing. This value is less than 1 and greater than 0. Okay. Now, I'll calculate f of minus 1.5. We will see what you will get. In place of x, you write minus 1.5 in this. In place of x, I am writing minus 1.5 minus step minus 1.5. Okay, that equal to minus 1.5 minus, what is step minus 1.5? In previous classes we learned step minus 1.5 is minus 2. Okay, so if we simplify this, what you will get? You will get minus 1.5 minus of minus is plus 2. This is 2 minus 1.5. 2 minus 1.5 is 0.5. You observe this answer is less than 1 and greater than 0. For example, I'll take f of 100.2. Then what is f of x? In place of x, you write 100.2 in this. What you will get? You will get like this. 100.2 minus step 100.2. Okay. So what you will get? 100.2 minus step 100.2. We know this from the definition of greatest Ncert function. Its value is 100. So 100.2 minus 100 is 0.2. You observe this value is less than 1 and greater than 0. Here till now I just taken fractions here. 1.5 minus 1.5, 100.2. If I take f of 2, we will see what happened. F of 2 in place of x, in place of x you write 2. What you will get? 2 minus step 2. Okay, then what you will get? 2 minus step 2 value is 2. We know this in previous class. We know this from previous class. Step 2 is 2. 2 minus 2 is 0. You observe, we got answer 0. We are getting answer 0 or we are getting answer less than 1. And I'll calculate f of minus 2. We will see what you will get. In this, in place of x, you write minus 2. What you will get? Minus 2 minus step minus 2. Minus 2 minus, what is step minus 2? Whenever while calculating step values, if integer is there, same answer we will get. So step minus 2 is minus 2 only. So what you will get? Minus 2 plus 2 equal to 0. So from these examples you can understand that fractional part function always gives the answer less than 1. Less than 1 and 0 is possible and 1 is not possible. You can check for any real x value. This fractional part function never gives answer 1. So here first I'll write a range of this fractional part function so that you will get some clarity. What is the image of 1.5? Image of 1.5 is 0.5. What is the image of minus 1.5? Image of minus 1.5 is 0.5. What is the image of 100.2? Image of 100.2 is 0.2. That means what is the range? Range is set of all images. If you observe all the images here, all the images are in between 0 and 1. 0 is possible, 1 is not possible. Okay. Now I'll write domain of this fractional part function. Domain. We know that if f is a function from a to b, then set A is called domain. You look here, this set is what? This set is domain of this function. So domain of fractional part function is all real numbers. Now I'll write codomain of this function. Codomain. See, if f from a to b is a function, then set B is called codomain. Here, this R is called codomain. So codomain of this function is R. So we learn domain, codomain and range of fractional part function. Now we will see what is the notation of this fractional part function. Fractional part of x is denoted by, look here, this notation. This notation is fractional part of x. It means, what is fractional part of x? Fractional part of x is nothing but x minus step x. How we read this as? We read this as fractional part of x. Fractional part of x is defined as x minus step x. For example, you see, you calculated 1.5 value na. What is fractional part of 1.5? You see, what we got here, fractional point of 1.5 means 1.5 minus step 1.5. What is answer you got? Answer you got as 0.5. Till now, we learn the definition, domain, codomain, range and notation of fractional part function and few examples to understand fractional part of function. Now we will learn how to draw the graph of fractional part function. You observe here, to draw the graph of fractional part function, I consider the coordinate axis. When I take x value 0, what is fractional part of 0? Fractional part of 0 is 0 minus step 0. Look here, 0 minus step 0. 0 minus step 0 is 0. 0 minus 0 is 0. So fractional part of 0 is 0. Now, if we take x is 0.25, what is fractional part of 0.25? See, fractional part of 0.25 is 0.25 minus, in this I am substituting 0.25. 0.25 minus step 0.25. 0.25 minus step 0.25 is 0. So what you will get? You will get 0.25 only. Fractional part of 0.25 is 0.25. Fractional part of 1. Fractional part of 1 is 1 minus step 1. 1 minus step 1. 1 minus step 1 is 1. 1 minus 1 is 0. So here I consider some values. I'll take few more values. First, I'll draw the graph for these values. We will see what happens. Here, the point 0, 0 is there. I'll mark that point. This is 0, 0. 0.25, 0.25. Approximately, that will be here. This is 0.25, 0.25. 0.5, 0.5. That will be here. 0.5, 0.5. 0.9, 0.9 will be here. Okay. Try to understand. This is 0.9, 0. When I take x value 1, I am getting 0 here. 1, 0. The point 1, 0 will lies here. Please catch this point. The point 1, 0 will lies here. Now, you see, I'll take few more different values here. We'll see what happens. This is the point 1, 0. I already marked here. 1.25, 0.25. 1.25 will be here. 0.25 is there here. Please get the point. 1.5 is there here. 0.5 will be here. Okay, so 1.9 is there, 0.9 is around here. Okay, when I take 2, x is 2, 2, 0, 2, 0 will comes here. Please try to catch these things. Now I'll join these points, we'll see what happens. You observe here, I'm joining these points. You see what happening? If we join all these points, you can see that I'm getting like a line. It is like this, 0. 1, 1 point is a part of this graph. No. So here I'll draw a open circle. Okay. So this is closed circle. This is open circle. Similarly, you join these points. We'll see what happens. If we continue this further, then the graph looks like this. Okay. You look here. The graph looks like this. This is the graph of fractional part of function. Okay. How we denote the fractional part of function? Fractional part of function is denoted like this. How we read it as fractional part of x. How to draw the graph of the function f of x equal to 1 by x. We are drawing the graph of the function f of x equal to 1 by x. Here you need to observe few things. What is the value of f of 0? F of 0 is 1 divided by 0. What is 1 by 0? In the denominator 0 is there, then this is not defined. So, domain of this function is all real numbers except 0. Domain of this function is all real numbers except 0. So, you need to keep this point in your mind. In the domain, 0 is not there. Okay. To draw the graph of f of x equal to 1 by x, I'll take some x values and I'll calculate respect to f of x values like this. You observe here, these are some x values and respect to 1 by x values I'll calculate. When x value is 0.1, what is the value of 1 divided by 0.1? 0.1 is nothing but 1 by 10. 1 divided by 1 by 10 is what? 1 divided by 1 by 10 is 10. So when x is 0.1, 1 by x value is 10. When x is 0.5, what is 1 divided by 0.5? 1 divided by 0.5 can be written as 1 by 2. 1 by 1 by 2 is 2. So its value is 2. If I take x value 0.9, 1 divided by 0.9, that is 1 divided by 9 by 10, that is 10 divided by 9. If we calculate this, you are getting 1.11. So when x value is 0.9, 1 by x value is 1.11. When x value is 1, 1 by 1 is 1. When x value is 10, 1 by 10 value is 0.1. When x value is 100, 1 by 100 value is 0.01. When x value is 1000, 1 by 1000 value is 0.001. 0.001. You observe here, after 1, as x values are increasing, these functional values are approaching to 0. You need to catch this point. As x values are increasing, f of x, 1 by x values are approaching to 0. They are. Now I'll draw the graph of f of x equal to 1 by x for these values. Next, I'll take negative values also. You observe here, I consider the coordinate axis to draw the graph of 1 by x. Now I'll plot these points. 0 is not a part of this domain. So when x is 0, the function is not defined. 0.1 comma 10 means it is somewhere around, it starts from here 10. Okay. Next 0.5. 0.5. If we take here 0.5, we are getting 2. 0.5 comma 2 means this will be here. 0.9 is 1.11. 0.9 approximately you will get here 1.11. Okay. When you take x is 1, 1 by x value is also 1. That means the point 1 comma 1. 1 comma 1 is here. When you take x is 2, take x is 2. If I take x is 2, 1 by 2. 1 by 2 value is what? 0.5. When you take x is 2, 1 by 2 is 0.5. 2 comma 0.5, the point will be here. Okay. You take x equal to 3. 1 by 3 value 0.3. Okay. So, and when you take x is 10, this value is close to 0. When you take x is 100, this is very close to 0. Like that, this graph will continue further. Now, you join all these points, how the graph looks. You observe here, the graph will look like this. And it never touches this x-axis here. The graph will look like this. Okay. If I take negative x values, if I take minus 0.1, see here, when x is negative, 1 by x is also negative. This will be minus 10. When x value is minus 0.1, 1 by x value will be minus 2. When x value is minus 0.9, 1 by x value is minus 1.1. When x value is minus 1, 1 by x value is minus 1. When x value is minus 10, 1 by x value is minus 0.1. Like that, you see x value is negative, 1 by x value is also negative. That means x coordinate is negative, y coordinate is also negative. That means this graph will be in third quadrant. How the graph we got here, if we plot these points and join all those points, you will get the graph like this. You see, the graph will be like this. It is important to remember the graph of 1 by x. We use this very frequently while doing JEE problems. This is graph of the function f of x equal to 1 by x. This is the first problem in exercise number 2.3. In this first problem, total 3 bits are there. First I taken this first bit. In this class only we will complete all the 3 bits. You observe in the question only given it is a relation. Okay, which of the following relations are functions? They given it is a relation. We need to identify whether it is a function or not. With arrow diagram, we can easily identify whether it is a function or not. You observe in this relation, what do you know about these all first elements? 2, 5, 8, 11, 14, 17. What do you know? We know that all these elements belongs to first set. So I'll write these elements in first set. What do you know about these second elements? You see, all second elements are 1 are there here. All the second elements are 1. That means in second set, only one element is there, that is 1. Now, you see what they given, 2 is related to 1. They given that this 2 is related to 1. And they given that this 5 is related to 1. How do you know 5 is related to 1? You see here, they given order pair 5, 1, that means 5 is related to 1. You see order pair 8, 1, that means 8 is related to 1. 11 is related to 1. 14 is related to 1, 17 is related to 1. Now, I written this relation in arrow diagram form. Okay, now we need to check whether it is a function or not. What is the definition of function? First, I'll explain as per the definition. Next, I'll give a trick also. For every element in first set, there exists only one element in second set. You take the element 2, how many elements exist for this element 2? There exists only one element, that element is 1. For the element 5, how many elements exist in second set? There exists only one element, that element is 1. See, for 8, how many elements are there? There exists only one element in set B, in second set, that is 1. Like that, for every element in first set, there exists only one element in second set. That's why it is a function. If you feel, as per the definition, it is difficult to understand, in other words, we can say like this also. every element in first set is used, it is used only once, then it is called a function. We already discussed the same thing in the definition of a function. Every element of first set is used, it is used only once, then it is called a function. So what we say here, we say that given relation is a function. Once we identified it is a function, they are asking give the reason. Because of what reason you are saying it is a function. You write that. The reason is, you see I written here, it is a function because for every element in first set, there exists only one element in second set. Because of this reason, we are saying it is a function. Okay. And you see in this question, if it is a function, then determine its domain and range. They are asking to write its domain and range. What is the definition of domain of a function? If f from a to b is a function, look here, if f from a to b is a function, then this set A is called domain of the function. Here, as it is a function, then this first set is called domain of this function. What is domain of this function? 2, 5, 8, 11, 14, 17. This is domain of this function. And they are asking range. What is the definition of range? Range definition is set of all images of domain set. Set of all images of domain set. What is image of 2? 1. Image of 5? 1. Image of 8? 1. Image of 11? 1. Image of 14? 1. Image of 17? 1. All the elements of domain set image is 1 only. So the range of this function is singleton set 1. Now we'll see the solution of second bit. You observe this is the relation given in second bit. We need to identify this relation is function or not. So I'll go with arrow diagram so that we can easily discuss whether it is a function or not. You observe here from this relation we know that all these first elements are in which set? All these first elements are in first set. So I'll write all these first elements in the first set. And we know that all these second elements in order pairs are in second set. So I'll write all these second elements in second set. Now you observe this ordered pair 2, 1. What it means? It means that 2 is related to 1. 2 is related to 1. Order pair 4, 2. That means 4 is related to 2. Order pair 6, 3. That means 6 is related to 3. 8 is related to 4. 10 is related to 5. 12 is related to 6, 14 is related to 7. Now you see that it is a function or not. What is the definition of function? For every element in first set, there exists only one element in second set. Here it is very clear, for every element in first set, there exists only one element in second set. So it is a function. In other words, how you can check? Every element in first set is used, it is used only once. You can observe here. All the elements are used, it is used only once. Because of that reason, we can say it is a function. Yes, therefore, I'll write that given relation is a function. Now, they are asking to give the reason. Why you are saying it is a function? See, it is a function because of this reason. It is a function because for every element in first set, there exists only one element in second set. That's why this relation is a function. You see here, if it is a function, they are asking to determine its domain and range. Now, I'll write its domain and range. As it is a function, then first set is known as domain. So, what is the domain of this function? Domain of this function is 2, 4, 6, 8, 10, 12, 14. Okay. Next, they are asking what is range of this function? Range. What is the definition of range? Set of all images of domain set. What is image of 2? Image of 2 is 1. Image of 4 is 2. I am writing all images of domain set. Image of 6, 3. Image of 8, 4. Observe the diagram. Image of 10, 5. Image of 12, 6. Image of 14, 7. So these are all images of domain set. So this is the range of the function. Now we will discuss third bit in this question. Okay, this is the third relation. Okay, this is the third relation given in the question. Now we know that all first elements belongs to first set. So I written all first elements in first set. We know that all second elements in order pairs belongs to second set. So I written these second elements in second set. Now you observe the relation. First order pair is 1, 3. That means 1 is related to 3. Okay. Next, second order pair is 1 is related to 5. They given like this. 1 is related to 5. Next, 2 is related to 5. They given like this. Is it a function? We know that for every element in first set, there exists only one element in second set. You observe for the element 1, how many elements exist? There exist 2 elements. But as per the definition, for every element in first set, there exists only one element in second set. But here, the element 1 is having 3 elements. Okay, so it is not a function. In other words, how we can discuss? Every element in first set is used, it is used only once. Here, all the elements of set are used, but one is used twice. Because of that reason, we can say that it is not a function. Therefore, given relation is not a function. They are asking reason why it is not a function. Because for the element 1 in first set, there exist 2 elements, 3, 5 in second set. Because of this reason, we are saying that it is not a function. Now, they are asking, if it is a function, determine its domain and range. As it is not a function, there is no question of its domain and range. This is second problem in exercise number 2.3, functions chapter of class 11. You observe what they are asking in this question. Find domain and range of following functions. We need to find domain and range of these functions. F of x equal to minus modulus of x. Many students feel difficult to understand domain and range of a function. Here, to explain domain and range of this function, I'll take few examples. You see, what is f of x? F of x is minus modulus of x they given. You calculate f of 2, we see what we will get. F of 2 minus modulus of 2. Minus, what is modulus of 2 value? We learned this in theory part. Modulus of 2 is 2. So, f of 2 is minus 2. Okay. F of minus 2 I will calculate. In this, in place of x, I'll write minus 2. Minus modulus of, in place of x, I'll write minus 2. Equal to minus, what is modulus of minus 2? We know that modulus of minus 2 is plus 2. Okay, so here plus 2. Similarly, you take f of 100. You calculate f of 100 minus modulus of 100 minus, what is modulus of 100 value? Modulus of 100 value is 100. So, like that, you take any real value. You take x as any real value. You take x as any real value for respect to y value exists. What you need to observe here, this function is defined for all real numbers. This function is defined for all real numbers. You take x as any real value. For example, if I take f of 2 by 3, what is f of 2 by 3? Minus modulus of 2 by 3. That equal to minus modulus of 2 by 3 value 2 by 3. You take x as any real value. We are getting one unique element here. That means, what is the domain of this function? Domain of this function is all real numbers. This minus modulus of x is defined for all real numbers. If you take any real value, this f of x is defined. That's why this domain is all real numbers. What you say about range of this function? Range of minus modulus of x. What is range? Definition of range is set of all images of domain set. From these examples only you can understand what is the range. You see here, f of 2 is minus 2. That means image of 2 is minus 2. Image of minus 2 is also minus 2. Image of 100 is minus 100. Image of 2 by 3 is minus 2 by 3. You observe these are all images. If you observe these images, all these are negative numbers are there. All these are negative real numbers are there. So, whatever real value you take in x, its answer is a negative real number. Is it possible we will get 0? You see here, you calculate f of 0. What is f of 0? Minus modulus of 0. That equal to minus modulus of 0 value is 0. Minus 0 is nothing but 0. So, image of 0 is 0. From these examples, we can understand that all images are negative real numbers. 0 is also possible. So, what we say about range? Range is all negative real numbers including 0. That means we can write like this. Minus infinity to closed 0. That means all negative real numbers will come here. As I am writing closed bracket, 0 is included. For infinity, we always write open bracket. Or else the same answer you can write like this also. All negative real numbers including 0. Like this also you can write this answer. Now you see the solution of second bit. What they given? F of x equal to root over 9 minus x square. Students will feel difficult to understand this. But only simple logic is there. Root 4 value is what? Root 4 value is 2. Root over minus 4 value is what? Root over minus 4 value is not defined. Whatever is there in under root, it must be positive. What they are asking? Root over 9 minus x square they are asking. Domain of this function. If this 9 minus x square is negative, then this function is not defined. So, whatever is there in under root, it must be greater than or equal to 0. So, here we will start answer like this. 9 minus x square greater than or equal to 0. This point you need to remember. Root over 9 minus x square domain if you want to find, you need to remember that 9 minus x square is greater than or equal to 0. Okay. Here, for an inequality, if we multiply with a negative real number, this inequality sign changes. For example, you see, 2 is smaller than 3. This inequality correct only, na? 2 is lesser than 3. When I multiply with negative number, what is the relation between minus 2 and minus 3? Minus 2 is bigger than minus 3. We know this. Minus 2 is bigger than minus 3. What happened? For an inequality, when we multiply with a negative real number, inequality changes. So what I'll do here, I'll multiply with minus. I'll tell you why we are doing all this. Multiply with minus. When we multiply with minus, this will become minus 9. This will become plus x square. The same thing I'll write like this. X square minus 9. I multiplied this with minus. When I multiplied with minus sign, this greater than changes to less than or equal to. Minus 0 is 0. A square minus b square is a plus b into a minus b. So here this can be written as x square minus 9 can be written as x plus 3 into x minus 3 less than or equal to 0. We have this formula x minus a into x minus b is less than or equal to 0. Then x belongs to closed interval a comma b. This is the formula you will learn in linear inequalities. Here a is less than b. Here when I equate this to 0, you will get minus 3. When I equate this to 0, I will get plus 3. You can observe here minus 3 is smaller than plus 3. So what I can write here? I can write that x belongs to closed interval minus 3 comma. What happened? You take any x value in this interval, you substitute in this, 9 minus x square will be positive. If you want, you can check. So what is domain of this function? Domain of this function is closed interval minus 3 comma 3. Now we need to write range of this function. Students feel difficult to understand what is its range. Actually it is easy if you know the definition of range. What is the definition of range? Set of all images of domain set. What is f of 0? 9 minus 0 is 9. Root 9 is what? Root 9 is 3. So what is image of 0? Image of 0 is 3. Now I'll calculate f of 1. I'm taking all x values in this interval only because range is set of all images of domain set. F of 1 root over 9 minus 1. 9 minus 1 is 8. What is root 8 value? Root 8 value 2 point something will be there. 2.67 something will be there. Root 8 value. I am taking all x values in this interval. F of 2. You write in place of x, you write 2. What you will get? 2 square is 4. 9 minus 4 is 5. Root 5 is 2 point something 1 to something will be there. 2 point something. I will calculate f of 3. In this, in place of x, you write 3. 9 minus 3 square. 3 square is 9. 9 minus 9 is what? 9 minus 9 is 0. So root 0 is what? Root 0 is 0. Similarly, if I calculate f of minus 2, you see what answer you got for f of 2. F of minus 2 also will get the same answer. F of minus 2. In this, in place of x, you write minus 2. Root over 9 minus 2 whole square is 4. 9 minus 4 is what? 5. Root 5. You see this answer same. So like that, whatever x value you take from this domain set, you observe the answer. It is in between 0 and 3. It is in between 0 and 3. 0 is possible, 3 is also possible. All answers are in between 0 and 3. So what it tells that? It tells that all images of domain set are in between the interval closer to 0 and 3. That means all real numbers in between 0 and 3. 0 is possible, 3 is also possible. So the range of this function is closed interval 0, 3. This is third problem in exercise number 2.3. Relations and Functions chapter of class 11. You observe this question, what they are asking. A function f is defined by f of x equal to 2x minus 5. Then write down the values of these things. They given that f of x equal to 2x minus 5. F of x is 2x minus 5. We need to write down the value of f of 0. F of 0. You can observe in this, in place of x, 0 is there. So in this function, wherever x is there you write 0 to get f of 0 value. What is f of 0? 2 of 0 minus 5. 2 into 0 is 0. 0 minus 5 is minus 5. So f of 0 value is minus 5. Now you see the second bit. Second bit they are asking to calculate f of 7. What is f of 7? In place of x, here 7 is there. So in this function, wherever x is there you write 7. Then what you will get? 2 into 7 minus 5. 2 7s are 14. 14 minus 5 equal to 9. Now see the third bit. We need to calculate f of minus 3. You observe, in place of x, here minus 3 is there. So in this function, wherever x is there you write minus 3. 2 into minus 3 minus 5. That equal to 2 into minus 3 is minus 6 minus 5. Minus 6 minus 5 equal to minus 11. Therefore, f of minus 3 equal to minus 11. Now we will see the solution for next problem. They given t of c equal to 9c by 5 plus 32. You observe here, this is the function they given. So I written the given function t of c equal to 9c by 5 plus 32. Now we need to find all these values. First we will see the solution of first bit. We need to calculate t of 0 value. You observe, in place of c, here 0 is there. So in this function also, in place of c, I'll write 0. Then what you will get? 9 into 0 divided by 5 plus 32. 9 into 0 is 0. 0 by 5 is 0. 0 plus 32. 0 plus 32 is 32. So t of 0 value is 32. Now we will see the second bit. T of 28. In this function, in place of c, 28 is there. So in this function, wherever c is there you write 28. Then what you will get? 9 into 28 by 5 plus 32. 9 into 28 is 252 divided by 5 plus 32. You take the LCM. LCM is 5. What you will get? 252 plus 32 into 5 is 160. So 252 plus 160 is 412 divided by 5. So this is the value of t of 28. Now third one, t of minus 10. You observe, this is the given function. We need to calculate t of minus 10. In place of c, you write minus 10. In this function, in place of c, you write minus 10. Then what you will get? 9 into minus 10 divided by 5 plus 32. 9 into minus 10 is minus 90 divided by 5 plus 32. Take LCM. LCM is 5. What you will get? Minus 90 plus 32 into 5 is 160. 160 minus 90 is 70. 70 divided by 5. 5 in 70 14 times. It will get cancelled. So t of minus 10 is 14. Now we see the last bit. You observe this fourth bit. What they are asking? We need to find the value of c. They are asking to find value of c. For that, what information they given? They given that t of c equal to 212. They given that t of c equal to 212. We need to find the value of c. Okay. You observe they given what is t of c. What is t of c? 9c divided by 5 plus 32. So in place of t of c, I'll write that 9c divided by 5 plus 32 equal to 212. I need to find c value. So I'll simplify this. 9c divided by 5 equal to 212 minus 32. 212 minus 32 is 180. So 9c divided by 5 equal to 180. 9 in this 180 20 times. You take 5 to this side. C equal to 20 into 5. 20 into 5 is 100. So the value of C is 100. This is fifth problem in exercise number 2.3, Relations and Functions chapter of class 11. You observe what they are asking. Find the range of following functions. We need to find range of these functions. Students will feel difficult to understand these questions. What is range of the function? You observe this diagram. It is a function because for every element in first set there exists only one element in set B. That's why it is a function. Now what is image of 1? Image of 1 is A. That we write like this. F of 1 is A. What it means? It means that image of 1 is A. F of 2 is B. That means image of 2 is B. F of 3 is A. That means image of 3 is A. Similarly, image of 4 is B. What is the range definition? The set of all images of domain set. The set of all f of x values. Try to understand. What is range? The set of all images of domain set is called range. Try to understand. Range is nothing but set of f of x values. Set of f of x values. This is important. You observe here. To find the range, I need to find out f of x values. I need to find out f of x values. We will see the solution for first bit. You observe in this first bit, they given f of x equal to 2 minus 3x and they are saying x is a real number and x greater than 0. This information they are already given in the question. We need to find range of this function. Finding range of function is nothing but we need to find f of x values. So in this problem, I am trying for f of x values. What are the f of x values? Here you observe they given that x is greater than 0. What I am trying for? I am trying for what are f of x values. So here you observe in f of x minus 3x is there here. Minus 3x. So I need minus 3x. For that I'll multiply with minus 3 on both sides. Multiply with minus 3 on both sides. Minus 3 into x. Minus 3 into 0. Here what happened for an inequality? For example, you see 2 is less than 3. For an inequality, if we multiply with a negative number, inequality changes. Minus 2, minus 3. What is the relation between them? Minus 2 is bigger than minus 3. That means inequality changed. Less than changes to greater than. What I am trying to say, for an inequality, if we multiply with a negative real number, inequality changes its sign. So here, this inequality, I multiplied with minus 3 on both sides. So inequality changes. Okay. Minus 3x is less than, minus 3 into 0 is 0. Actually, what I am trying for? I am trying to get what are f of x values. Okay. You observe in this f of x here 2 minus 3x is there. Here I got only minus 3x. So how I'll get 2 minus 3x? By adding 2 on both sides. You observe here for an inequality you take one real number, add to it on both sides. What I am trying to say, for an inequality if we add a real number on both sides, inequality remains same. So if I add 2 to this inequality on both sides, then also this inequality remains same. So 2 minus 3x. I am just adding 2 on both sides. See here 2 minus 3x is less than 2 plus 0 is 2. Okay. So what is 2 minus 3x? 2 minus 3x is f of x. So I came to know that f of x value is less than 2. What we are trying for? We are trying for f of x values. What we got here? All f of x values are less than 2 we got. From this, I can write range of this function. What is range of the function? All the real numbers which are less than 2. So I can write it as range as open interval minus infinity to 2. Now we will see what is the range of second bit. You observe here in second bit we are finding range of this function f of x equal to x square plus 2. Range is nothing but finding f of x values that we discussed earlier. So I'll try for what are the f of x values. Here what information they given? They given that x is a real number. I am trying that what are the f of x values. I'll square this on both sides. For any real number, if we square, it will be greater than 0. There is a chance equal to 0 when x is 0. So when x is a real number, x square is greater than or equal to 0. Why I tried for x square? Because x square is there in this function. As we discussed, for an inequality, if we add a real number, inequality remains same. It won't change. So I'll add 2 to this inequality on both sides. Add 2 to this inequality on both sides. X square plus 2 is greater than or equal to 0 plus 2. Okay. So what is x square plus 2? X square plus 2 is nothing but f of x. F of x is greater than or equal to 2. What we are trying? We are trying to find range of the function. Range is nothing but set of f of x values. I got that f of x values, all f of x values are greater than or equal to 2. From this I can write range. Therefore range of this function is all the real numbers which are greater than or equal to 2. So I'll write the interval closed to open infinity. As I am writing closed bracket here, 2 is included, all the real numbers in between 2 and infinity. This is the range of second bit. Now we'll see the solution for third bit. You observe this, they given this information, f of x is x, x is a real number. We need to find range of this function. Range of the function is nothing but we are finding the values of f of x. We are finding the values of f of x. Here what they given? They given that x is a real number. You see, they given x is a real number. It is very easy bit. You see, what is x? X is f of x. What is x? X is f of x. Here in place of x I can write f of x. In place of x I can write f of x. So f of x belongs to R. That means we came to know that f of x is all real numbers. What do you say about range of this function? Range of f of x is all real numbers.